Welcome to EasyStats. EasyStats is an online tool built in R that runs in your local browser and allows the user to do various types of analysis, including a cutoff optimization for survival analysis in multiple datasets. First, let's show you how to install the software. Open the executable file, select or create a desktop shortcut, and click on Next. Now click on Install and wait for the installation to finish. Once it's completed, we can start using it. When the app is launched, it will open in your local browser. The app is divided into 3 tabs: Welcome, Survival Analysis, and Clinical Data Analysis. In the Welcome tab, you can see a brief introduction of the app and the different types of analysis you can perform. If we go to the Survival Analysis tab, we will perform Kaplan-Meier analysis for our markers of interest. The interesting part here is that you can upload several datasets at the same time, explore different cut points for your marker, and quickly generate ready-to-publish Kaplan-Meier plots. In this example, we will upload 2 different datasets. Once they uploaded, you can select your marker of interest from a drop-down list that contains all the markers in your Excel files. In this example, we will select marker 1. We will plot the p-value based on the percentile. In other words, we are going to create a plot that displays all the p-values for increases of 1% in our continuous marker. We click on Update and it generates the plot. Here on the x-axis, we have all the different percentiles with 1% increases. On the y-axis, we display the p-value. The dashed red line indicates a p-value equal to 0.0. Anything below the dashed line is significant, and anything above it is not. In addition, each cohort is represented by a color. Here red is cohort 1 and blue is cohort 2. The shape of the point also indicates if the HR for that cut point is above 1, represented by a square, or below 1, represented by a triangle. In this case, you can see that most of the cut points in both cohorts are below the dashed line and represented with a triangle. This means they are significantly associated with good prognosis. Now, we can select our cut point of interest. In this case, we will select the median, so we click on the 0.5 dot and it automatically generates 2 Kaplan-Meier plots, one for each cohort. In blue, we have the group with above the median values, and in red, the group with below the median values. In addition, the plot shows the p-value and the risk table. In addition, instead of plotting the p-value, we can plot the hazard ratio for each cut point. In this case, all the cut points are associated with good prognosis, so they are below the red dashed line, which in this case represents the neutral value 1. We can also remove the outliers, also in this case there are none. It is also possible to create Kaplan-Meiers based on the value of the hazard ratio, but the results would be the same as if done using the p-value plot. Now, we can go to the Download tab and download the plots as PNG or PDF. This will generate a zip file in your Downloads folder. If we open the zip, you can see the plots as PDF or PNG, depending on what you selected. Here I open the PDF to show you the Kaplan-Meier for both cohorts. Next is the Clinical Data Analysis tab. Here we have 4 options: marker correlation, marker by variable, marker comparison, and contingency table. Let's start with marker correlation. This function allows you to upload a CSV or Excel sheet file. In this example, we select cohort 1. Now, we select the markers that we want to correlate. By default, the first column in your file will be shown in the marker selection boxes. Here we select marker 1 and marker 2. We click on Plot Correlation and the plot is generated. We can also show the p-value if we select the Show Adjusted p-value if we select the box. In addition, we can choose between 3 different correlation methods: Pearson, Spearman, or Kendall. By default, the plot will show the Pearson correlation. If we want to download the plot, we will go to the Download tab and select the PNG or PDF options. Now we will show the marker by variable function. Here, we will plot the values of our marker in different categories. First, we upload one Excel sheet file. Here we uploaded again cohort 1. Now we select a variable, in this case ADIC. Since age is a continuous metric, I had to modify the Excel sheet to create 2 groups, one for less than 50 years and one for equal or more than 50 years. The plot will automatically generate. We can select different colors for the plot, and we can also select different tests. By default, the app will perform the student t-test. It is also possible to select Mann-Whitney test or an ANOVA test. If the variable selected has more than 2 categories, for example race, The plot will only be generated if the ANOVA test is selected. We can also download the plots as PNG or PDF. Now, let's do the marker comparison analysis. Here you can compare the levels on any two markers. First, to upload the Excel sheet, we will work again with Cohort 1. We select the two markers that we want to compare, in this case Marker 1 and Marker 2. By default, the test is the student's t-test. If we click on Plot, the graph will be generated. Same as before, we can also select the ManWDU as our analysis test. Finally, if we click on Edit Labels, we have the option to modify the plot title and the y-axis title. This will automatically modify the labels in the plot. Once again, if we go to the Download tab, we can save the plots as PNG or PDF. Finally, we can also create a contingency table with our data. For this, we will split the markers by the median value and study the proportion of high and low cases in each group of the variables of interest. First, we need to upload our Excel. In this case, we will go with Cohort 2. Now, we have to choose the variables we want to study. Here we will select age, sex, stage, and race. The markers we are going to study are Marker 1 and Marker 2. If we click on View Contingency Table, it will plot it. Note that if the table is too big, it will be divided into different pages. The p-value that is being displayed here is the corresponding to the Fisher's test. Finally, if we go to the Download tab, we have the option to download the plot as CSV, PNG, or PDF. When the tables are too big, the PDF and PNG options will show partially cut tables. However, you can always work with the CSV file and format it to your own preferences. We have finished analyzing our cohort, so now we can use the plots to quickly create a presentation with really nice graphs. Thank you very much for watching. If you find this tool useful, please share it with your friends and coworkers. We will also appreciate if you can cite our paper if you use this tool for your data analysis. We are not done yet. The files that you upload into the program must be Excel sheet files. For the survival analysis, it is important that the survival time column is named as time and the sensor column is named as status, as shown in the image. If there are missing values for the survival time or sensor, you might see some errors, like the 50 percentile is not giving even groups, so it will be better to delete from the Excel all the missing values.